So what's happening? You're casting this on YouTube, and we can have access to it later on.
Yeah. So what I'm going to do is I'll record this as well. I will I will chuck it on YouTube as well, just so it's easier to get because
The hold of, yeah.
because it'll just stay up there
Great.
forever.
Okay, brilliant.
Yeah. Okay. Cool. Looks like we've got a few people joining, so let's give it just a minute or so, and then we can start.
Let me get myself a drink in the meantime. Just dash to the fridge and to the place that must be visited.
Yes. Hi, Lee, how's it?
Hey Wayne, motivating yourself?
Yeah, good.
Yeah, sorry, we've got load shedding here now, so the UPS is just running a router and a few other things, lights and stuff though.
Yes, the important things.
Yeah.
Yeah, no, this load shedding is a huge pain. Jeez.
Yeah, we've got an hour left now, so let's hope it's over.
I don't know what time are they. Well, not that it matters, but that's good.
Yeah, I was busy processing some stuff, old photos that I found that I never touched on PixInsight earlier today while I was at the office. It was like a stressful day, so sitting and doing that while I was working. A nice image of M83, so let's hope that comes out decent enough.
It's always good to have images to process.
Yeah, now I've got a whole bunch of them. Actually, thought I lost them, but there's a ton of them. Geez, I think I've got about 7 or 8 different objects on there.
That's nice. Jeez.
Yeah.
Wayne, you mostly do monoband, isn't it?
Yeah, I do.
Narrow band?
Yeah. So it's just
a mono camera.
Yeah, because I got the mono camera. I will like from home here, because of the light pollution, narrowband works way better. But the RGB I'll do like if I'm going to darker site. Okay.
Which camera do you have for your?
The 1600 mm. Cool.
Okay, and for your one shot?
I don't have a one shot.
Oh, you don't have one. Oh, you just do RGB with one.
Yeah.
Okay.
Yeah. Yeah. No, I was using a DSLR, and then I managed to get hold of that mono cam, and that's what I've been using. It's not too bad. It kind of, I don't know if it's better or worse, even with the RGB. It just kind of makes it a little bit easier with the one shot, but it's not that bad. Okay. I think we should start. Okay, so for the other guys on here who don't quite know why we got to this, is Bunga here sent me some of his images, all of the flats and the darks and the biases and the lights as well, and asked me to, well, in the group he asked, can anyone help and have a look at the processing, and that's I said, yeah, sure, send it on and I'll take a look. And I did the processing on it, and then he wanted to get an idea of the workflow and what I did. So I think it was just easier to have like a Zoom call and actually share it versus trying to write it down and describe it, because obviously it's quite a few steps to get to it. I mean, this was the final image from using his data that it ended up with the Comet and the M10 in the background. So I just wanted to take everyone through like Comet processing in PixInsight. You can do this on anything. It works for mono as well. It's just slightly more steps, well, slightly a bit more tricky, but same kind of idea. I'm not going to go through absolutely every step. I'm going to skip out the WBPP because it's going to be unnecessary waiting for no real reason. But you did want to see the settings I was using. So when I added the bias, sorry, this is already got the master biases that it created. But I didn't change any of the settings in here for it. I just used the standard settings. And I didn't generate drizzle data because there was no real need to do drizzling on this. And I just chucked in all of the images. So I didn't try and perfect and throw away the less than perfect ones, because WBPP does a fairly good job of doing that. In the calibration here, just make sure CFA is ticked, but that generally does it by itself if it realizes there's the one-shot color images in here. Otherwise, everything was set to auto. And I said do image registration, image integration. So this was like kind of like the basic settings for it.
Now, Wayne, just a question, please.
Yeah, go ahead.
Did you use subframe selector at all? And
no, I literally just chucked them in. And
you took everything.
Yeah.
Okay. Okay. All right.
Yeah. I just chucked everything in. I wasn't being fussy with it, because I found that the WBPP does a pretty good job of managing the frames and throwing out the ones that are bad. I typically throw out the ones that are hideous, like the guarding has gone completely south, but yours were pretty decent, so I just chucked them in. So this is the image you end up. Oh, hang on, let me not do that. Sorry. Screen transfer functions I want. Okay, so this is the picture you end up with. Obviously, there's lots of processing to do, and the problem with Comet processing is you end up with this fantastic mess of a picture here.
Yeah, too right.
Yes. So to fix this, you need to do another set of settings. So you first have to do this whole stack your images normally, because you need your background, you need your star stacked, you need everything else in the image stacked. So that's, you have to do the step anyway, and you need the outputs of this stack here for the next step. So what you would do after getting that and just putting it in is you go to image registration and Comet alignment. Okay, so how Comet alignment works is you load all of your frames that you want to align, and then you will, I'll go through and show you how you select the start of the comet and the end of the comet. Now, don't select the lights, because I see what happened. Well, what happens is if you flip on a meridian, you'll find some of your images are halfway and the others are the other half. So when you go to try and select the start and end point, you can't select the start and end point of where the comet is, because the image is flipped and reversed. So what is easier to do is to go to the registered stack, because these have all been calibrated, drizzled, registered. So this hasn't been stacked yet. This has all just been aligned. So everything's aligned. Everything's kind of done already in this. Select everything here. Open all of it. Just give it a second to open. And I think I will go through and show you, like, if it doesn't quite capture. I think that a couple of them didn't have the comet in them at the end, but I'll show you that now. This is just taking its time. Okay. Cool. So it's loaded all of these. So to use this tool, you simply go to the first one, apply your stretch to it, just so you can see what's going on. Zoom in, and you just click on the head of the comet. So that basically find the bright spot in the comet. It doesn't have to be too accurate, because you can see it does a smaller circle around it. So what it's saying is this is going to be essentially the start of the comet, and this is what it's going to track. Okay, and then you go down to your last one and stretch it. Now, so this is what I found. Like, I think the comet is still there. Yeah, just
I think it's probably flipped the other side. Yeah.
no. So that's why you use the register, because if you don't use the register,
Yeah.
what happens
Yeah.
is the Comet ends up down here. Okay.
Yeah. That's the problem. Definitely, I had that because I got screwed up there. Yeah. Okay. Great.
Okay, so what you then just do is select the Comet over there, and now you have your start and your end, and you run the stack. So what it's going to do now is you can see it's busy processing all of these images, and it's going to align these, but on the Comet.
Mhm.
Oh, hang on. Did I not select the output directory? Sorry, hang on. I did not select the output directory. Sorry, you want to put these in an output because you want these. There we go. You want these as a you want these to be outputted. I just forgot to. So
Then they'll have a comment aligned prefix after that.
they do. So I like putting in a different directory. Otherwise, sometimes finding them in a stack of all sorts of things can be slightly trickier. So what this is just going to do is just going to run through. You can see it's already on the 49s, 50s, and there's 82. So it doesn't take too long to stack these, or to align these. So what it's going to do is going to align on it, and then you're going to do an integration on the stack. Okay. So that's done. The tool's done. We don't need that anymore. And what you'll see here is here are all of these aligned images, and it's added the CA _ CA to the end of it, so the Comet aligned.
Mm-hmm. Okay. Yeah.
Then the next step is the normal image integration. Okay. And what you want to do is just integrate all of these images again. Open them in here. Now, I'm going to do this wrong first, so you can see and you know what the problem will be. Because if you've done this and how to fix it, because you'll see if you don't try and get rid and reject the pixels properly, what's going to happen is you're going to have streaks of stars, which is going to be a nightmare to try and extract the comet from. Because basically what you want to do is you want an image with the comet with no stars, and you want an image of the stars. So we're going to pull out the stars from this, throw the comet away in this one, and then merge the images later on, because you've got this moving thing across a background of static stars. So you've got to try and manipulate it a bit. But if you don't do it and you don't reject these stars, you are going to find that you will get these streaking stars. You're still going to have a bit of a messy background. It's never clean. Okay, but if we look at this is going to be very difficult to pull out a comet from. Okay, because you've got all of these streaking stars. It's going to be very difficult to try and clean this up and get these stars out. So to fix that, in the image integration, okay, we go to, let's just close this up. Got the pixel rejection. Okay, the WinRAR Sigma clipping works quite well to do this, but if we just ran it as is with the Sigma high, you'll get some rejection of these stars, but it's not going to be great. Drop that to 0 and then run it again. So what this is going to do is to get rid of the very bright streaks in the image. And hang on. If my audio is dropping, sorry, PixInsight is currently taking everything off the machine. Okay, we'll just wait for it to finish the last one. Okay. Okay. So you can see our high rejection is now there. The low rejection, you can just close those. We don't need those. And now when you stretch this, okay, now the stars are pretty much gone in this image. And you've got left with the comet. We still have a bit of streaking going on of the stars. And if we just try to cut this out, you can see there's a lot of kind of mess in your image. But these are the two images we're going to work with. So let's just call this Comet. And this is just something. Okay, call it whatever you want. It doesn't matter. Okay, so the first thing we need to do is to run dynamic crop. And you can always crop your image later for personal tastes of how you want your thing. But basically what I'm wanting to do now is get rid of all this mess on the edges here. You can see where the stacking happened, where it's aligned. We want majority of this stuff gone. So if we go up to about there, this is the cleanest part, it looks like. You can of course do it how you feel, but try and crop out the majority of the mess. I mean, it's not so bad if you go a bit longer, you can definitely do it. Before you just execute, I'm sure you guys know, drag this process down onto the thing. Go onto this ticket, you can get rid of that dynamic crop, and then you just apply that there. So now both images are cropped the same. If we put this on here, it will get the same zoom. So now you have your two images that are the same size, so we can actually process them later on. If you don't crop them the same, you're going to have a problem later on when running the pixel math to try and put them together. Okay, obviously we're going to need to extract backgrounds. I'll just run ABE on this thing. You can run, oh, this might make it worse. Yeah, that's better. You can obviously run a dynamic background and spend far longer perfecting that on the image, but that's largely doesn't really matter for the purposes of this kind of processing comments. But I mean, the processing background's all the same. Then what I like to do is run, if you guys haven't used this, the Russell Croman's Noise Exterminator thing is a fantastic plugin. You can run it, so if you want detail, it's a bit high, run it down a bit, and the denoise, and we're still in linear space. So what this is an AI noise reduction for obviously deep space images. So it knows what stars are, it knows what nebula are, and it does an extremely good job of cleaning up the backgrounds. So
you're leaving the denoise at denoise setting at 90.
Yeah. Yeah. So you can see here is what it did.
And the DEET.
So you can we haven't lost the detail in this comet. The comet is still fine.
Yeah.
But we've killed all the noise in the background. Now play with what you want there. It's up to your personal preference as to what you like. In rich star field, I found dropping the detail down hugely. Otherwise, it makes these like halos around the stars. If you denoise it with the stars. So I would drop it way down. And exactly the number, you just kind of need to play with to see what you personally like in an image. It's just, you can see like that's a huge difference in the noise in this image, and it hasn't really affected the quality of the stars. So it's and it's pretty quick. It's a nice tool to clean up the images. Okay, let's just close this one for now. I don't need that right now. Okay, so the next bit is, if I just merge these images again, we'll have a problem here with this rest of these background artifacts that are still in here. So what we need to do is try and clean up as much as we can and select out this thing, get the rest of the background to black. So when we merge it, you don't have weird gradients or this weird smudge in the middle, which is going to mess up your M10 in the middle, and this here is going to mess up the other stars. So it's not going to look great. So one of the easiest ways is to do a range mask. And this is a trial and error. You need to play with this and see. Okay, obviously that's much too big. Okay, so that's still selecting a decent amount of the Comet. I can go smaller. We can easily clean up these other bits. I'll clean up these bits now. So what we also want to do is smooth it. Actually, we'll smooth it later. So we'll smooth it later. It's easier to clean it up with a clone stamp. So all you do is you apply, close this now, and you have your range mask. Then to clean this up, just use clone stamp on this, and let's set a big, okay, just literally clone stamp out all of these things. So it's hold to use clone stamp if you haven't used it before, hold Control down, and then it will be taking from this first, the X on the screen, it'll copy from there, a radius or around it, to the plus. So it'll take this black to the plus. Okay. So you can see you can just clean that up, clean this up. And I'm just holding the mouse cursor down. I'll zoom in now to get closer to that. And clean that up, and we clean this edge up. Yeah. Okay, now we need to just do a little bit of fixing up over here. And we can just drop this radius down here and clean up these bits around here. Okay. So these little dots are going to mean nothing really, because it's just going to be single pixels being copied across. Just double check it's all okay. Okay, when you're done, just click tick box and it will apply the clone stamp to this. Now, the other issue with this at the moment, you can use this, but it's a very harsh copy. So the best thing is to run convolution on it and just blur the image. Okay, so this is what the convolution is. Basically, you don't want to harshly cut off, otherwise when you do copy it across, it's going to look like you cut it out. So you want to blend with a bit of that background, a bit of the stuff around it, just to get a nice, smooth kind of looking copy. Exactly how much you do on this is up to you. So I applied that convolution, and this is the range mask we've got. Okay, so now we have these two. We want to apply the mask here. Just invert it, and we'll protect that. Obviously, you can tweak this mask a lot more. If you wanted to copy out some of this, you can start bringing some of this in faintly. You can just clone stamp and bring it further out. You can play with the range mask. This is where you spend the time to tweak and get the image perfect. However, for now, we know what we want to do. We just want to get rid of all of this stuff. Okay. It looks a bit weird now, but don't worry, we will. Okay. Okay, so what you're left with is your Comet. And it does look a little strange, but it's okay. We will do the processing later on, especially when you bring it back into the star field. You'll see it'll look a lot better. So while we have just the Comet here, now's a good time to adjust some of the colors, because you're going to be adjusting the colors of just the Comet and none of the star field later on. Otherwise, you can get these weirdly colored stars or over brightened stars. Where's that going? And again, this coloring is your personal preference of what you want it to look like. So play with it. And I'm not going to get exactly the same quality image as I did last time because I spent a bit longer playing with it. But yes, feel free to adjust it as you want. Multiply that, just reset it, up the saturation. Okay, so now you have a comet, and now you have a bit of a messy star field still. So you can run star masks and try and mask it off, but what is significantly easier is running StarNet. Hang on. Sorry, I want to go back a few steps. I know this is looking so. I know why this is looking weird. I'll go jump a few steps back. Okay. Let's just get rid of this thing. Okay, sorry. I had completely skipped a step off. Actually, I forgot to have screen transfer functions on. You need to stretch the images to the histogram stretch. Now, I've used to be using the normal histogram stretch, which you can still see here on my taskbars, but what I've been using lately is this generalized hyperbolic stretch. So this is pretty nice for stretching nebula and all sorts of faintly detailed things out. I mean, I can definitely go into more detail about how this works, but it gives you a nice control over how the stretch is done. Number there, 2157. So what you can do is, obviously here's your 25% mark, so you want to try and put it up. But now, this here, the local stretch intensity, expands this. It makes this base wider, so you can see how narrow, it's very narrow, goes to much wider. This moves where the point is. So if we move this all the way out, there's way too much. And you can see this sort of pulls it in. Without going into too much detail, we will pull this just past there and apply it. Okay. So that's the stretch image. Again, you can stretch this a bit more, but generally going too far, you'll get a bit of a messy looking image. And then let's do the same thing to the stars. Okay, just zoom in so you can see where that point is. That is 196. So the stars, you obviously don't want to bring them all the way up to this 25% because I find you overdo them. And you can see you've actually got quite a bit of like this faint background nebula going on here. So if you really stretch this out, it is there. You'll obviously need to tease it out quite carefully, but they're like IFN is sitting in that background here, so that is pretty cool. Okay, that's probably okay as a stretch. And I would normally, when I'm doing this properly, would take this process a lot slower and do this multiple times slowly to get a decent looking image. I think let's just do once more to bring the stars up a bit. 1 force
So Wayne, if you weren't using generalized, which one would you use
The normal
in view of that?
the normal hyperbolic
Just the
stretch.
manual histogram stretch?
Yeah, the normal histogram stretch. Okay. Don't have to worry about the brightness of the background in this because we're going to ignore that. Okay. And no, we don't need to disable it. Okay, so you get some nasty stretch stars. You can play with it a lot more. So what we want to do then, here's this range mask we did and did that process again. So we'll just apply the range mask to this. And kill this background. Okay. Apply that. Do it again. Okay, so that's, I don't want to go too far because if you find if you go too far, you will end up messing up the comet. So you need to try and protect the comet as much as you can in this. But you see I've still got all sorts of these other fuzzies in the background. So what I've done for this is you just do the clone stamp again. And we can make this a bit bigger again. And we can just cross these things out. Because we don't want these coming across and these other streaks coming across in our final image. Because what we're going to do is we're going to merge this onto that. And it's going to look a bit weird if you have these kind of splotches in your final image. You don't have to be incredibly accurate because it's going to be, this rest of this background is going to be very faint and hard to see. I mean, you can obviously be a lot more pedantic about it if you've got some fantastic data and you are wanting to make it a really great image. So yes, be as fussy as you want, but in interest of time here, I'm just going to do it a bit quicker. Otherwise, this is the fiddly part. And now we have this one thing here we need to just clean up a little, because this guy is that bright star that happened to be in the background. So what I'll do is I'll pick it, I won't go black on here, otherwise you'll see a harsh transition. So I'll just pick a spot that's kind of in the same tone as where you are. And if it's getting a bit too harsh, like that was a bit too harsh cutting away there, I'll drop the opacity down. So what this does is it will copy less of this at once. And if you go slowly with it, you can see it like it's not completely clearing it away. So you can very slowly remove and fix these areas that will look weird to be copied across. Now, that is good enough to be copied over. And what we can do in here is just go and do the curves again. And let's bring up these a little bit. I know this curve generally looks okay for comics. Bring up the greens. I mean, again, this is your personal preferences of how you want it to look, and how much blue, how much green you want in the comet. I do suggest doing it slowly, otherwise overdoing it will make it look really weird in the final image. Okay, so we've got a comet image out here, we've got a star field over here. So now what we need to do is run this star net on this star field. And make sure you say create a star mask. Otherwise, you're just going to pull out everything that's not a star. So this is fantastic.
Wayne,
Yeah.
why do you prefer StarNet to Star Exterminator?
Because I haven't bought Star Exterminator.
Oh, okay.
Yeah. I think the best with those two is actually the best thing to do is have both and test both, because both StarNet works better in some situations. Star Exterminator works better in others. So there isn't a one that is always better.
Okay.
So I would do both, and to this, I found StarNet is pretty good. Where it's less than perfect is some of the extremely nebulous regions with a lot of stars. It's not amazing, but it's good enough. Some of the questions. Yeah, no issues. Audio StarNet 2. Yeah. I have seen it do things at times, but if you want perfection, take both and try. Okay, so you can see this is the non-star that's removed. So now we have a star field. No, and all the stars gone. You don't need that because that's what we're going to use. Now we're going to use these two. I wouldn't apply any sharpening to this image because sharpening on stars tends to make them look really horrible. I always would sharpen a nebula, process all of this. So what's great is this: you separate the two out, work on your nebula, process it, do all your curves adjustments, leave the stars alone. Stars, when you start doing curve adjustments, it's easy to blow them out. It's easy to make them look messy. So a final kind of thing to join these two together is to take both of these images and merge them together. And it's a very simple pixel map. It's simply Comet image plus this image, and there's your Comet. Okay, it is slightly overdone in terms of the processing, which is doing it quickly and not spending time. But that's the basics of it. I always apply color profile because getting my monitor settings, so I basically embed the color profile in it. Afterwards, I then go to curves again and fix the redness that has come up on it. Otherwise, I find this image, these colors are applied when I send it on WhatsApp or put it on Facebook or whatever, which is not what you want to do because it looks really ugly if you try and post it anywhere. And it just, I know for me, it's just a little bit. Actually, you can see a bit of the background nebulosity going on here, which is nice that it came out. Okay, so that's mostly removed the red. You can do a bit more of it. And now's when you can start the final tweaking of the image. If it's a bit too green, if it's a bit too blue, just do your normal curves adjustments. Do any saturation you might feel is going to help. Generally, at this point, it's extremely small adjustments of it. Otherwise, you overdo it and you kill these stars. And it does look a bit messy. If you are worried about this like cluster in the middle here, you can fix that by leaving some of the stuff in this image you copied across. To try and blow this out, or if you basically you want this little bit of glowing patch sitting in this image, and when you put the two on top of each other, it's going to bring that center back to the M10. But yeah, that's the gist of Comet processing. It's a multi-step process because you've got these two images that aren't aligning. You need to process and pull this Comet out separately, and it depends on your data as to what it looks like. If I show you when I did on the for the mono one I did, if you have a look at these Comet lines here, it worked a lot better at pulling out these stars. So it was a bit easier to make a range mask on it. The color was a bit flatter, so it pulled out a bit better. Actually, this one is by far the worst. I think like the red and green was came out really nicely. No, so it just depends on the filter and how much you want to pull out. It's a little more frustrating to do the mono because you have to stack all of these and do like multiple steps. But the process is the same for mono data in it. The color is definitely easier to use. You do see there's some background anomalies here, but that's just because I didn't spend time doing good background extraction. But yes, that's the process. So if you guys got any questions on it?
Wayne, before combining them, you didn't do what was it? Is it a process called linear fit or something like that?
Yeah, so you don't need to because you're pulling out this background.
Mm-hmm.
So you see, I've made this background basically dark, and this is where that slight, if you look at here, you can see that slight glow is coming from here. So you don't need to do a linear fit when you're putting these two together. If I go to this workspace where I did your data originally, this is what I pulled out. So you can see this background is a lot cleaner, and I spent a bit more time dealing with this range mask. So if we blended these, if we blended these, what's it called? Comet to clone. Was it just Comet 2? I think I did. Yeah. So you can get a lot better type results. You can see this is not overdone nearly as much as this one is. That was just a quick processing of making this and overdoing this. But you need to spend. This is where you need to spend and fiddle with your time. Is getting this mask nice, cleaning it up, processing this mask nicely, and processing the data nicely. Otherwise, when you blend it here, you see like there's no weird color shifts here, because I spent way more time in doing this. And if you look at the other stuff, it looks better, but it's the same kind of thing. It's just spend your time, do it carefully, and adjust it, fiddle with the mask, and that to get it just right. Unfortunately, yes, as you know, it's again personal preferences. Some people may like it other ways, but the processes are the same. It's you want to take the comet out of that image or the stack image, and you want to put it back into your star field. Now, depending what the data looks like and so on, and when doing it, is how much work you need to do to create a mask, how much work in clone stamp you need to do to clean up the background, and so on. So, and you can even take that mask into Photoshop, save it, put it into Photoshop, process it some more, to really make it like. So it depends how much time you want to spend doing the mask, but that is where you get cleaner looking images coming from it. Because all you do is you save the mask off as a PNG, go into Photoshop, edit the mask in Photoshop, and come back into here, open it up and use that image as a mask, and you can have a better processed image. So yes, it's about how much time you want to spend and what kind of effect you want. Because when I did this it looked better to me, but I mean it may not appeal. This may have too much of the background in it. But yes, you need to fiddle with it and adjust it to your liking.
Okay.
Yeah.
Thanks a lot.
Yeah, I mean, as you keep all of these, make clones, just clone this, clone it to make a clone, and then work on it. So when you get to a point you like, clone it and do some more work, clone it and do some more work. So you can at least go back to the point that you liked, because I find when I work on it a lot, I get overly into it. You can sometimes overwork it and it becomes bad. Then you undo and you forget like where you were, or you can't get back to the step that you remembered. So yes, just take your time, play with it, Again, this background clonal style is not perfect. I mean, there's way better times. I spend a lot more time doing in the stretching. I spend a lot more time in the mask creation to get a better looking image. But yeah, it's not difficult. It's just a few more steps. It takes a little bit longer because you have to process two images, integrate, align them separately, stack them separately, or integrate them separately, pull out what you want, and merge them again together. But yes, it's fairly simple. Any other questions?
Thank you very much.
No other questions. Okay. Great, guys. I mean, thank you for joining. It was 45 minutes, not too long. But yeah, I mean, if you guys have any other questions or would like to see anything else in PixInsight or go through anything else, I mean, let me know, and I can definitely set up more of these to go through, and from what I've learned and so on, to share with basic techniques, thinking about it, and how I do it. Obviously, there are many ways how to do this stuff, so it's not the one way only, but hopefully you can learn something and apply techniques to your things or adjust the techniques. Cool, awesome, thanks, Rob.
Okay, Wayne, just one last one. I was thinking I'm receiving my I'm picking up my L-Extreme dual band filter, which I'll be using with my one-shot camera, the ASI 294MC. But obviously, some of the pictures can obviously look a bit boring. It's just red. And apparently, one can do a false Hubble palette. You can do what is it? Is it HOO and false Hubble palette and all that? I'd love to do a processing. Maybe I get some data, put some hours in, and then send you some data that maybe we could look at how one can extract something like currently. I think the Veil Nebula is not quite high up over here. I could spend some hours and get that data. And then perhaps we could do a session and just see how I'll, split up the channels and recombine them and try and get something, that sort of resembles the Hubble palette and to make it look more interesting.
The Veil is fantastic for the HOO and especially with the L-Extreme, because it's quite easy to pull out the red and the blue from it with the channel extraction. The Hubble palette on that is going to be not as nice on that target because of your not a lot of S2 in that image. I mean, it's there, but it's not as easy to pull it out of that because it's not as clean. There are better targets to pull out that Hubble, to do that fake Hubble palette. But yeah, you can definitely put it out. You can definitely do it, and you can send me the data. The HOO is by far the easiest one to do because it's basically red and blue. The full Hubble is a little trickier because S2 and HA sit very close in the red. So to try
would, for instance, would the rosette be better for the Hubble palette?
I think it's got to have better S2 in there. So yeah, it'll probably be better to do a Hubble palette on that. And yeah, so you can take the data, send it to me. I'll do it beforehand, and then we can set up something and take you through it. I mean, if you also want to look at narrowband processing, I mean, we can go through narrowband because I've obviously got a lot of narrowband data. And a lot of the narrowband techniques are what you're going to use in the Hubble palette anyway, because what you're doing is you're going to be putting out channels, black and white channels, and then processing it. Obviously, slightly different, but similar kind of techniques. And as you see, this is why I've got a whole pile. I mean, I skipped a whole lot of steps of stuff I normally do, like the deconvolution and all that I normally always run. And as Tion saying, Veil it depends. Some targets, like probably like the lagoon, might be good because that's quite bright and you can get quite a lot of nice data on it. And that has got some decent S2 in it. But you need to find those targets that have got decent S2 for doing a nice Hubble palette in the one shot. But yeah, and as I said, I've skipped out a whole lot of steps I normally do. I mean, I normally spend a lot more time with the dynamic. I never normally really use this automatic background extraction. I've got it here because sometimes it's nice to just quickly check things. I normally spend a lot more time doing deconvolution, and we can go through that if you want. I think I might have done a deconvolution. There are many different types of noise reduction in PixInsight. We can go through those at some point, but I found now, since he's released this noise exterminator, that this is by far the quickest and simplest to use, because you don't need to fiddle too much with. There's only 2 parameters, and you can adjust it to your liking and save it as a process here, and just keep loading it every time and largely use it. I find that this now has kind of replaced these other TGV denoise and the other denoising, the MLT noise, because when you look at these are way more complicated, and some images, depending on your data, you have to change these settings, and you go again and again and again to find the right points. I found that this is just simple.
You don't have to fiddle around with masks and so on. That can be quite
it's
a pain for the noise. I mean, it can take with that. It's just
it's
a
really
click
good.
away. It really is good. I can swear by it. I mean, I also forked out for both. I was so convinced by noise. I went for star 2, so I've got both.
Yeah, no, I got this one because this is
pretty good.
It's good. It's really good, and but we can go through like HDR and that as well, because some targets like Orion, fantastic with HDR because it's extremely bright in the core. But even then, on like Lagoon, also playing with HDR is quite nice, because if you do it softly and gently and not overdo it, you can actually pull out a lot of data and pull out a lot of that when you get that over brightened center after the stacking. You can tone it down and get a bit more contrast going on, so you can see the detail of it easier. And then the StarNet has made it so much easier, and the Star Exterminator so much easier to do sharpening. Before, sharpening was a pain because you had a mask and it never quite worked as well as removing the stars and putting them back again afterwards. It's a much easier now. You can get a bit lazier and get pretty good results. But yeah, so just let me know what kind of things you want to look at. Obviously, there's lots of stuff you can do in Pixel now. But in the kind of SHO palette, we will have to use Pixel. Well, I don't have to, but it's nice to use Pixel Math to get slightly different results. Cool. Okay. Thanks.
Do you use color masks much, Wayne? Color masks? There's a guy who's got those scripts which you can download for color masks.
Yeah.
How do you find that?
Well, they're here. I mean, the color masks you can just use them.
They're there too, yes.
Yes. So I do use them. It depends on what I'm doing. I don't always. It depends on what kind of coloring you want to do, where you want to target color, how you want to adjust an image. So yeah, it's try each one and keep playing. Like if you want to do this and pull out the blue because you want to make the blue brighter, you can focus on the blues here now. So if you put just that as on and focus just on those blues, we can make them sorry, I put the wrong way around. Just that you can make it way more blue. So it depends. It depends. Like it's not that I always use them. I use them when I want to do certain things. So yeah, I do. It just depends. But like some of this is my favorite friend for deconvolution, because this makes making these finding the PSF way easier than doing it yourself. makes it way faster and just simpler. Cool. Thanks, guys. I think that's it then for this evening. But yes, feel free to, on the WhatsApp groups, just ask, and if there's anything in particular people want to see, like how to process something or an idea that you want, or something. I mean, I'm going to go into a lot more detail myself into the WPP at some point, because it's got a lot more functionality there than people normally use. So maybe you can share that at some point. But yeah, just let's chat on the WhatsApp groups and let me know, and then we can. And I'll share this live stream here afterwards, so you guys can find it and watch it. But yeah, thanks, guys. Have a good evening.
Thank you very much, Wayne. Thank you very much for your time and brilliant presentation and great teaching skills, being able to pass on something quite complex and making it look next to trivial is not easy, but obviously you seem to have some skills in that area.
It's a pleasure, thank you. And I mean, it also helps me learn, because the more I talk about it, the more I say it, it definitely makes it easier. When I have to do it and go through the steps myself to be able to explain it, I think it helps a lot in learning it myself. So, no, it's only a pleasure. Cool. Thanks, guys.
Thank you,
Thanks,
sir.
Wayne.
Have a good evening.
Cheers.
Cheers, Bye.
Good night.
Cheers.
Thank you very much.
Cheers.
Yes. Thank you, Wayne. Bye-bye.